Today in science class, we're going to take a look at IXL G.1 calculating velocity from time and distance, and IXL G.2 calculating distance from velocity and time. In lesson 1, what is motion, we learned how to calculate speed. Another form of speed, another way speed is described as velocity, and that equation for speed was listed as speed equals distance over time. We could also say that velocity equals distance over time if you incorporate the idea that velocity is the speed of an object with the direction of that object. So velocity and speed are calculated the exact same way. Speed or velocity equals distance divided by time. You're going to see that in G.1 we're going to use that division problem based on the distance that we're given and the time that it took for something to travel that distance. And then in G.2 we're going to calculate distance from velocity and time by using the distance equation or dividing in that opposite sense. So let's take a look at G.1, calculate velocity from distance and time. I'll show you a couple example problems and get you started, and then you'll be able to work on completing this until you get to that expert level or that mastery level of a score of 80 or greater. G.1, calculate velocity and time distance. Gwen rode her motorcycle down a straight freeway for 0.6 hours at a constant velocity. She rode 60 kilometers in that time. What was her velocity? You'll notice that each time it's asking you these questions as you read through, it's going to give you the two pieces of information that we're looking for, the distance and the time. We take the distance and divide by the time, so she went 60 kilometers in 0.6 hours. And then another key giveaway in terms of how you're calculating this is to look at what they have in terms of the units, kilometers per hour. So you take the kilometers, 60, and then divide by hours as your denominator to give you your unit speed. In this case, we're going 60 divided by 0.6, 100 kilometers per hour down the freeway. A bat flew 850 centimeters directly toward its cave at a constant velocity. If it flew the distance in 2.5 seconds, what was its velocity? Centimeters per second, so I take centimeters, 850 divided by 2.5 equals 340 centimeters per second. A goldfish swam directly across a pond at a constant velocity for 1.8 seconds. It swam 81 centimeters in that time. What was its velocity? Notice here it's giving you the time first, then the centimeters. You just have to recognize to put centimeters divided by seconds in this case because your answer is looking for centimeters per second. So don't be fooled when it writes it in that otherwise order or put seconds before centimeters. Don't say you're going to divide 1.8 by 81. You still have to put the right unit in the numerator, which is 81 centimeters divided by 1.8 seconds to give you your answer. So you have 81 divided by 1.8 equals 45 centimeters per second. Luna's friend was rollerblading at 12 meters per second. To try and catch up with her friend, Luna ran 87 meters down the street at a constant velocity. She ran that distance in 15 seconds. What was Luna's velocity? And notice here, the only way they're trying to throw you off in terms of your critical thinking is giving you two different pieces of information. It says Luna's friend is rollerblading at 12 meters per second. Luna is now running 87 meters in 15 seconds. So you take these two pieces of information instead of this first overall speed, and you're trying to calculate what the speed of the second piece of information is. So 87 meters in 15 seconds. You take 87 divided by 15. She's traveling at 5.8 meters per second down the street. For 39.6 seconds, Walter was hang gliding at a constant velocity. In that time, he moved 495 meters to the southeast, and a flock of Canadian geese flew past him at 17 meters per second. What was Walter's velocity? Now they're talking about the geese here as another way to throw you off, give you this second piece of information that you don't need. Here you're looking at meters per second. It says what was Walter's velocity, so how far did he move and how long did it take him to move. In this case, you've got 495 divided by 39.6 because we're looking for meters per second. He was traveling at 12.5 meters per second. In a garden, an earthworm crawled 144 millimeters north in 10 seconds at a constant velocity. While the earthworm was crawling, it was passed by a butterfly flying at 1,500 millimeters per second. What was the earthworm's velocity? So again, it gives you the butterfly information of millimeters per second. We're looking for the earthworm because that's what the question is specifically asking us. 144 millimeters north in 10 seconds. So you're going to say 144 divided by 10 gives you 14.4. Obviously much slower than the butterfly. The last portion, Ben has 120 meters away from his car after shopping. It took him 20 seconds to push a shopping cart 1/3 of the way directly to his car at a constant velocity. What was his velocity while he was pushing the cart? Now, I'm going to get this one wrong because I want you to see what the question is asking and how you're supposed to break this down. Notice it says Ben was 120 meters away from his car after shopping. It took him 20 seconds to push the shopping cart 1/3 of the way there. So you have to immediately think, well, he didn't get 120 meters in 20 seconds, but that's what it wants you to say. He only went those 1/3 of the way there, so what's 1/3 of 120 in those 20 seconds? That's actually how fast he's traveling because he didn't travel the 120 meters in those 20 seconds. So to actually calculate this, you would say that it took him 20 seconds to go 1/3 of the way there. It means you could take this value and multiply it by 3 to figure out the time it took to get all the way there, or figure out what is 1/3 of this distance and then divide that by the 20 seconds. In this case, Mr. Shane again just wants to get this wrong. I'm going to say 5 and click submit so we can actually see the explanation. So in this case, an object's speed is distance over time. Speed is measured units of distance in unit per time. Some units measure speed are per second or kilometers per hour. An object's velocity has the speed and the direction of its motion. So it gives you a reminder of the definitions that we already know, speed and velocity, and the calculation of that. Now in order to solve this, it's pointing out that there are two different pieces of information here. How far he's traveling, and then the time it took him to travel, but there's this third little bit of information, 1/3 of the way directly to his car. So this question tells you that Ben moved a certain distance in a time of 20 seconds. The distance is, the question does not directly tell you the distance Ben moved in 20 seconds. Instead, it tells you that you've moved 1/3 of the way to the car, but you know that that total distance is 120 meters. To find the distance, you need to write an equation to find 1/3 of the distance to Ben's car. So you take the total distance and divide by 3. In this case, it's 120 divided by 3. So he went 40 meters in 20 seconds. So you got to kind of create a problem for you on how you take these two first pieces of information and that third piece and then find the actual meters per second that they're traveling, break that down. So in this case, he finds out that 120 meters is the total. 1/3 of that is 40 meters. 40 meters in 20 seconds means he's only going 2 meters per second. Got it? Try again. In 7 minutes, Brandon paddled his kayak east halfway across Lake Spolo at a constant velocity. Lake Spolo is 980 meters wide from west to east. What was Brandon's velocity? Remember, in this time, it gives us the time, it gives us the distance, but it says that Brandon only paddled halfway across Lake Spolo at a constant velocity. So if the lake is 980 meters, he went half of that. So half of 980, 980 divided by 2 is 490. He went 490 in 7 minutes, so I take 490 divided by 7 to get my actual meters per minute. 490 divided by 7 is going to give me 70. I got that correct. A raindrop has 28 meters above the ground. Falling straight down at a constant velocity, it took the raindrop 2 seconds to fall half the distance to the ground. What was the raindrop's velocity? So the raindrop was 20 meters above the ground, but it only fell half that distance in 2 seconds. So what's 1/2 of 28? 28 divided by 2 is 14. 14 divided by 2 is 7, so it's 7 meters per second straight down. Bob biked north at a constant velocity for a total of 15 minutes. In 1/3 of that time, he moved 2,000 meters. What was Bob's velocity? Again, it gives you a total of 15 minutes, and 1/3 of that time, he moved 2,000 meters. So he went 2,000 meters in 1/3 of 15. Well, 15 divided by 3 is 5, so 2,000 meters in 5 minutes. You're going to say 2,000 divided by 5 is 400 meters per minute. Mr. Shane did 10 of those questions with you. I hope that that helps you with your understanding in those different levels. Obviously, calculating speed is distance divided by time, and it gets to this level where it's throwing in extra information. You have to break that down as it throws in that fraction to calculate either the total distance or total time. Again, you're trying to find that basic rate of whatever it's asking you, kilometers per hour, meters per second. Break that down with that second step in there, and then simplify what you're trying to find. In G.2, we're calculating distance from velocity and time, and our equation is going to change just a little bit. I'm going to get this one wrong to start and take a look at what our new equation looks like. Here you have speed and velocity. Speed and velocity, again, distance divided by time. But to calculate distance from speed and time, you're going to actually rearrange the equation. To find an equation for distance, you can start with the equation for speed. In the equation for speed, distance is divided by time. To get distance on its own, multiply both sides of the equation by time. So speed times time and distance times time will cancel out the time on the side to solve for distance. So distance equals speed times time. Distance equals speed times time. Distance equals speed time time. Hopefully that helps you remember it. Now when I'm actually going to go to calculate, I have to find distance by taking the speed and multiplying by the time. In this example, Emma is riding her motorcycle down a straight freeway at 100 kilometers per hour. If the velocity remains constant, how far will Emma ride in 0.6 hours? So I take 100 and I multiply by 0.6 because distance equals speed times time. So I multiply those two things together to solve the equation. 100 times 0.6 is 60 kilometers, and there's my answer. Got it. Let's try that. For 1.2 hours, a yacht sailed east at 45 kilometers per hour. In what time? In that time, how far did the yacht sail? So I take the speed and multiply by the time. I take 45 times 1.2 equals 54 kilometers. And I got it right. For 1.7 seconds, a barracuda swam toward a coral reef at 4 meters per second. In that time, how far did the barracuda swim? So 4 meters per second, you'd say 4 times, that's your speed, times the time, 1.7 seconds, equals 6.8 meters. Kangaroo is hopping toward a lake at 10 meters per second. If its velocity remains constant, how far will the kangaroo move in 31.2 seconds? 10 meters per second, you take that speed, multiply by the time, 31.2, get a total of 312 meters. Stage 2. A supersonic jet is at an altitude of 14 kilometers flying at 2,400 kilometers per hour toward the east. At this velocity, how far will the jet fly in 1.5 hours? So again, distance is calculated by multiplying speed and time. A supersonic jet is at an altitude of 14 kilometers flying at, so it's telling you two different pieces of information here. The altitude doesn't tell you how fast it's going. Flying at this speed is how fast it's going. So it gives you just one other piece of information to kind of decipher and say that this is important or this isn't. We're looking for speed and we're looking for time. So I'm going to take 2,400 and multiply by 1.5. Give me an answer of 3,600 kilometers. For 4.6 seconds, a seagull flew at an altitude of 15.1 meters and a velocity of 15 meters per second. Again, they're throwing in that altitude as just this extra piece of information. Here you've got 15 meters per second for 4.6 seconds. You multiply those two things together. 15 times 4.6 is going to give you a distance of 69 meters. We'll jump to the next level so you can see what the most difficult problem is going to look like. Mona's swimming in a river. She can swim downstream up to a maximum speed of 72 meters per minute. If she is swimming downstream at half of her maximum speed, how far will she swim in 5 minutes? Okay, so it's giving you the time here, but it's not giving you the speed. It's telling you what her maximum speed is, but because it says half of her maximum speed, you got to take this 72 and divide it by 2. So there's an extra step thrown in. 72 divided by 2 is 36, multiplied by 5 minutes. Tells us how many meters she's traveled, because our distance equation is still the same. It's still the speed that she's traveling times the time that speed is taking place. Here's another example. After shopping, it took Bryce 66 seconds to push his shopping cart to his car. He was moving at 2 meters per second. His daughter walked beside the cart for 1/3 of the time it took Bryce to reach his car. How far did Bryce's cart move while his daughter was walking beside it? So it's telling us his daughter walked beside the cart for 1/3 of the time it took Bryce to reach his car. It took Bryce 66 seconds to push his cart to his car. So for 1/3 of that, you have to find 66 divided by 3, 22 seconds, and you've got 2 meters per second. You take 22 times 2. You'd say that she was traveling 44 meters in that time that she was walking next to the cart. A hockey puck slid across an ice rink in 6 seconds. It slid from the center line to the goal line in half of that time at 9 meters per second. What's the distance the puck slid between the two lines? So here, all the way across the rink in 6 seconds, it slid from the center to the goal line in half of that time. So half of 6 is 3. That would be 3 seconds, and then you multiply by the speed, 9 meters per second. 3 times 9 equals 27 meters. Okay, so hope that helps. That is the most difficult portion of what you're going to see in G.2 when you're multiplying to find distance. Again, you're multiplying the speed by the time. For these last ones, make sure that you look for the fraction or the way in which they're changing how that speed or time is. And once you've kind of simplified that, then you can still go back to the distance formula and multiply speed times time. One last example. Quincy is biking north twice as fast as his sister, Carrie. Carrie is biking at 100 meters per minute. So he's biking twice as fast. That means she's going 100 meters per minute, he's going 200 meters per minute, and he's going for 5 minutes. So 200 meters per minute times 5 equals 1,000 meters. All right, did 10 questions on each of those. Hope that helps you completing and calculating velocity and speed, and then using that same type of equation to calculate the overall distance traveled from speed and velocity. God's blessings.